Hi. The idea of this research came from the huge heat wave hitting Chicago in the summer of 2006. Um, During the heat wave, more than 100 people died, and most of them live in the urban area, and all of them died at night. It is usually our understanding that the urban is warmer than the surrounding area. That's what we call the urban heat island effect. And at night, the plants in the surrounding croplands will release the water vapor to the atmosphere. That's what we call the evapotranspiration process. So when the evapotranspiration process and the urban heat island effect, they met together, the heat index will increase. That's how we actually feel, how hot we actually feel. So imagine you're in a tropical forest when you are feeling very hot and you're sweating, but your sweat won't dry out because the atmosphere is even more humid than your skin. So you're feeling much hotter than the actual temperature is. So this is the case of the interaction between the crop and the urbanization in the case of the heat wave in Chicago. So, however, the current climate model can't simulate this kind of interaction in a very coarse resolution. That's why I introduced this graph here. So in this graph, Chicago is in this green box. However, the model can't identify whether it's the urban or the cropland or Lake Michigan. So by increasing the resolution to this, that, and that, the model can identify a more realistic land surface use and generate a more sophisticated physical process, which will increase the model performance to give us a better simulation and understanding of what's happening in that case. So in this result, the results, what I got from this case is even more surprising, out of my expectation, because in this, it is really a complicated case that, because in Chicago, there's not only urban or cropland, there is Lake Michigan. So you can't ignore the lake effect. So at night, when the winds will blow from the lake to the urban, and that would bring the huge source of moisture and intensify the intensity of the urban heat, the interaction between them. And also in atmosphere, when we increase the resolution of the model can be more sophisticated to generate it and simulate it to resolve the convection in the local scale, which will give you more precipitation in this case. So imagine, finally, in the future, under climate change, what would the situation be if this kind of heat wave happened again in a warmer and more humid climate background? That's the question that we try to answer in the future. Thank you.